Okay. So again, inverse trig functions and their graphs. So we are finding the values of inverse sine, inverse cosine, and inverse tangent. I was just lazy in how I wrote that. Inverses. Recall that for a function to have an inverse, it must be what we call 1 to 1. Are the trig functions 1 to 1? The answer is no, they are not. Because the trig functions are not 1 to 1, by definition, if we take the inverse then, they do not have inverses that are functions. They do not have inverses that are functions. We can verify this with the horizontal line test. So the horizontal line test is something that you do to the original equation, and it tells you if the inverse is a function. So for example, if I did the horizontal line test to number 15 from the homework, does it pass? No, because it hits more than once. So I should say that first. Passing means it hits once. Fail means it hits more than once. So there is like a spot here where it hit once, but for the most part it's hitting more than once, yes? And if it hits more than once anywhere, then it fails. So this would fail the horizontal line test. This in and of itself is a function because it passes the vertical line test, but its inverse will not be a function because it doesn't pass the horizontal line test. So the vertical line test is for what you're looking at in that moment. Is it a function or not? The horizontal line test is if you do it to the function, it's telling you about its inverse. It's not telling you about what you're looking at. If you found the inverse, would it be a function? So if you look at other graphs that we have, like the sine, if I draw horizontal lines through it, is it going to pass? Does this pass the horizontal line test? No, because it touches multiple times. So if it fails the horizontal line test, its inverse is not a function. So this is a function in and of itself, because if I pass vertical lines through it, we're good. But if I pass horizontal lines through it, we are not. It is possible, however, to restrict the domain. And if we restrict the domain, then what we have will be 1 to 1. So we need to do a domain restriction so we don't have a recurrence of these things over and over again. So if we look at just sine and we restrict it from negative pi over 2 to pi over 2, look at just this little graph. It looks like a funny S. If I do horizontal lines through it, will it pass the horizontal line test? Yes. So its inverse would, yes, be a function. And oh look, here's its inverse. Remember, the inverse is a reflection over the line y equals x. So from here to here, we're going to the inverse. So this is my graph of sine with the restricted domain, and then this is the inverse. Do you remember that -1 up there in the exponent spot means inverse? We've seen that notation before. Okay, so this is the graph of y equals sine x. This is the graph of also y equals sine x, but with a domain of negative pi over 2 to pi over 2. What does it mean that I used brackets instead of parentheses? What do the brackets tell me? Including. Yep. Oh, is that what you're going to say? I didn't know if you were going to ask a question. So yes, including. So that means these two endpoints right here and here are all included. So it's not going up and getting infinitely close. It's actually including that point as well. Okay. So then when we switch over to the inverse graph, it looks like this. And again, inverse graphs are a reflection over the line y equals x. So the line y equals x kind of looks like that. So that's what we're reflecting over. So that's reflecting over that part. This is reflecting up over this part. Okay, let's continue talking about it. So we've got a lot to talk about, and then these problems are only one step. So there's a lot of kind of front loading, but then when we do the problems, it's one step and you're done. The definition of the inverse sine. So it has different names because, you know, why not? Sometimes we call it sine to the negative 1, and sometimes when we're feeling a little silly, we call it arc sine. It doesn't matter. They're the same name, okay? Just kind of like different friends maybe call you different nicknames. These are all different names for the same thing. So sine to the negative 1, arc sine, written either way, those mean the same thing. We do have a cancellation property. I'm going to come back to that in a second. Let's talk about how to do these. So these problems feel like Jeopardy in comparison to what we've been doing. So what we've been doing so far is we've been saying rotate, go to that spot and find the point. Agree? I'm going to tell you rotate to a spot and then find the angle you rotated by. That's how it's going to change. So it's almost like we're doing the opposite of what we've been doing over that restricted window. So we want to find each value. This says find the inverse sine of pi over 2. Okay, my unit circle's coming back out for a second. So when we're doing sine and tangent, this is where I'm allowed to live. So that blue spot is where I'm allowed to live for arc sine and arc tangent. This is my spot on my graph where I'm allowed to go. This is my no-fly zone. I'm not allowed to go into this region at all on my graph. I'm only restricted to this little spot for both sine and for tangent. Because if I move out of that region, then I'm going to get a doubling up of values. So I'll show you what I mean by that. I want to see what angle gives me a sine value of root 2 over 2. Okay, so look at the blue. In the blue region, where do I have a sine value of root 2 over 2? It only happens once. Where is it? Pi over 4. So that is the answer to the question. Like I said, it's a lot of information for one step. So the answer is pi over 4. Do you see how if I had done the top region and I said, what angle gives you a sine of root 2 over 2? How many answers would you have? 2. So this is why we're restricting it, because in this way we only have one solution. So when we talk about the answers, we're going to talk about them in terms of pi over 6, pi over 4, pi over 3, pi over 2. For these answers, the only way I can get there is going this way. I can't loop around and get there this way. So when I talk about these numbers, this is negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Does that make sense? Because in order to give them the values like these numbers that are here, I would have to go through the no-fly zone. And I'm not allowed to go through that way. So we're going to be limited only to these. Do you see how few answers you can have? You're going to get a lot of the same answers over and over again. So every year when people do this homework, they're like, oh my gosh, I got pi over 4 again. You sure did. If there are only so many angles, there's only so many different answers you can get. Okay, we're really limited. All right. Let's see. What do I want to say next? Hold on. I'm going to come back to the cancellation property. I'm still not ready to talk about that. We'll come back to that. Let's do another one of these first. I'll come back to the cancellation property when we get a little bit further in here. All right, let's do another one. Inverse sine of negative root 2 over 2 is my next problem. Oh, you can't see that. Inverse sine of negative root 2 over 2. By the way, we're going to finish up this page, and then we're going to stop for today. So this is just so you know where we're headed. Okay, so again, this is like Jeopardy, so I'm asking you the reverse of what I've been asking you this whole time. Before, we've been finding parts of the ordered pair. Now I'm giving you a part of the ordered pair, and I'm saying, how'd you get there? What angle is it? Okay, so take a look. In your restricted region, in your fly zone, when is my sine value negative root 2 over 2? Where is it? 7 pi over 4. If I were to say 7 pi over 4, I'd have to get there in my no-fly zone. Can't do that. Negative pi over 4 is how I'm going to write it. Are those coterminal angles that truly end up in the same spot? Yep, but we have to get there this way. Have to. So, what we said is, somebody said 7 pi over 4, and I was like, in terms of the end location, yeah, that's correct. But I can't get there without going through my no-fly zone. So in order to get there through only the fly zone, I have to call it negative pi over 4. Because if I did 7 pi over 4, I'd have to go through here to get there. Am I allowed to go through here? No, restricted airspace, bad. I have to go just this way, which would be negative pi over 4. Okay, let's do another one. I'm going to call this D down here. We're going to do another one. Let's go inverse sine of root 3 over 2. Inverse sine of root 3 over 2. So take a look. Don't say the answer. Take a look. Staying in your fly zone, what angle would take me to a y value of root 3 over 2? Positive root 3 over 2. Which one is it? I heard somebody say it. Pi over 3. So again, we're looking for angles today. We are angle hunters. We are looking for what angle. Next one is a trick question, but I want you to tell me why. I want to find the inverse sine of 5 over 4. I'm telling you it's a trick question. Why is it a trick question? It doesn't exist. 5 over 4 is bigger than 1, yeah? Yeah. In my unit circle, we talked about, like, at the very beginning, that it's a unit circle because its unit of measure is 1. Its most important unit of measure, which is the radius. So if my unit of measure, the radius, is 1, can I ever go above 1? No. So this one is going to be no solution. So it is possible to have answers today that are no solution. So think about your sign for a minute. We can get up to 1. We can get down to negative 1, right? That's where we live, in between 1 and negative 1. So if this number is bigger than 1 or smaller than negative 1, it's no solution all day long. So that's kind of our parameter for where we can live versus where we can't. So since 5 over 4 is greater than 1, it is not in the domain from negative pi over 2 to pi over 2. Okay. So it is not in that domain. And it is larger than the range we are allowed to be in. Because the range goes up to 1 and down to negative 1. All right, now I'm ready to talk about the cancellation property because we've finally gotten to one where we can talk about it. Okay, look at this problem. It looks trickier, right? Because there are 2 trig functions in there. Use what you know. Use your instinct. I think is the right word here. Use your instinct. What do you think is going to happen with the inverse sine and the sine? They're going to cancel each other out, and my answer is going to be what? Pi over 6. Okay. Let's talk about this for just a minute and why that works. Let's start here. What is the sine of pi over 6? What is the sine of pi over 6? 1/2. Okay, so could I replace this with 1/2? Yeah, because that's what it is. What is the inverse sine of 1/2? Meaning, what angle gives me a sine value of 1/2? Pi over 6. So do you see how that works? So you can reason it through either way. Let's go back to the rule for just a second, though. The rule says that we are allowed to use that rationale as long as we live in the restricted window. If we don't, then we're going to have to do it in 2 steps like I told you after, right? Like I said, reason it out this way and then go the second step. So if it does not live in the restricted window, then you have to actually use the process we used a minute ago. Okay? So you have to do 2 steps instead of 1. All right, let's look at another problem. Let's see. So since pi over 6 was in the restricted interval from negative pi over 2 to pi over 2, we could use the cancellation property. Okay? Let's do another one, but this one you're not going to be able to use the cancellation property. All right. Is 13 pi over 6 in my restricted window from negative pi over 2 to pi over 2? What? No. Okay, somebody said yeah. No. Negatory. Okay, let's think about where 13 pi over 6 is. 6 goes in there twice with a remainder of 1, yes? So let's think about where we landed. So I'm going to think about just this part. I'm going to think about just what is the sign of 13 pi over 6. So 13 pi over 6 would be here. Agree? Okay, what's the sign at that spot? 1/2. So the inverse sign at 1/2. So what angle would give me a sign value? What angle would give me a sign value of 1/2? Pi over 6. So do you see how this one, they couldn't just undo each other and the answer wasn't 13 pi over 6? In a way it was, because is this the same spot on my unit circle? So in a way it was. But again, we can't use the method of the elimination because we weren't in the correct window. All right, same ideas, all the same ideas. Cosine though. Arc cosine can live in this region. So this is the fly zone for arc cosine or inverse cosine. So this is my fly zone for arc cosine. It can't go down here. Think about your x values. Think about your x values. This gives us no double up of x values. That's why it's those 2 quadrants instead of here and here. Because if I'm here and here, do you see how I'd have multiple x values that are the same? So the green has to be where I can live for my arc cosine. Again, same stuff applies. We're looking at just a chunk of it, so that way it stays a function. So we're looking 0 to pi is what we're looking at. And we can call it cosine to the -1, or we can call it arc cosine, either way. Let's do a couple examples. Here we go. Cosine to the -1 of -√3 over 2. By the way, just so you know, there's going to be a part C. All right, so we're doing arc cosine of -√3 over 2. So look at your fly zone. Look at your fly zone. Where is my cosine? What angle would take me to a cosine value of -√3 over 2? 5 pi over 6. Okay. Like I said, it's a lot of work to explain it for that to be your answer. Like we had a lot that we had to talk about first, and then the answer is pretty quick to get. Okay, next one. This one, the cancellation property is going to work. So do you see how 5 pi over 6 lives in this window between 0 and pi? So I can use my little cancellation property, and what's my answer? 5 pi over 6. If you're like, ooh, that felt uncomfortable. I don't know that that's true. Then process through it. What is the cosine of 5 pi over 6? The cosine is negative root 3 over 2. What is the inverse cosine of negative root 3 over 2? Meaning which angle would get you here? Still 5 pi over 6. Okay? So you can think about that and process it either way. Okay, last one. And then you've got some homework problems to practice on. Okay. Is 7 pi over 6 in my restricted domain between 0 and pi? Bummer. Okay, here we go. Let's find the cosine. So again, I'm going to ignore this part. We're going to work our way out. Cosine of 7 pi over 6. So let's go to 7 pi over 6. There's 7 pi over 6. What's the cosine? Negative root 3 over 2. So really what I'm doing is I'm finding the inverse cosine of negative root 3 over 2. But I can only stay in that restricted part. So if I stay in the green restrictions, what value is it? Where am I at negative root 3 over 2? And do you see what I said was true about your answers? Oh, Miss Vessel, I keep getting the same answer. Yeah, you do, because there are so few values that it can be. So, yep. Okay, ready for homework? You've got a bunch of problems, but these are pretty quick for the most part. Here we go. We are on assignment number 5, page 411 through 412, numbers 3 to 4, 10, 23, 26 to 27, 31, 33, and 38. Again, these are 1-2 step problems at the most. Tomorrow is a little bit trickier because we have tangents, so we're going to have to do a division step. It's not much trickier, but it's a little smidgen trickier.